Our developmental computational model predicts, right, no meaningful input differences across SES when it comes to learning the syntactic islands knowledge from this part of the input, right? We predict the same outcome of being able to generate this judgment pattern. So this is great because we know how the input is predicted to cause that knowledge to develop, right? Remember, that's what our learning theory is telling us. We know which building blocks then are going to be particularly important for the success of this knowledge development. And we can look at what those are. So for example, key building blocks for success involve complementizer that, so CP that in this case. And this is because two of the islands, that is the weather island and the adjunct island, only differ from grammatical dependencies by the complementizer used, right? So here's our grammatical dependency. What does the teacher think that Lily forgot? So we have an embedded dependency with our non-island structure, our tends to embedded clause with complementizer that. And our weather and adjunct islands, right, they look the same, except it just so happens the complementizer is whether, the complementizer is if, right, in terms of the structures that are going on here. What does the teacher wonder whether Lily forgot? What does the teacher worry if Lily forgot? Versus what does the teacher think that Lily forgot, right? So that's key building block, right? Syntactic trigrams that involve complementizer that. Okay. And so you can see that here, right? Like that's really what it boils down to under this particular learning theory that's embedded in our developmental computational model. So what this means is that children would need to encounter grammatical WH dependencies that involve complementizer that. These are actually pretty rare overall, and certainly pretty rare in child-directed speech. So in our samples of low SES and high SES child-directed speech, we only found 2 in each case, even though the sample sizes were actually quite a bit different. Still only 2 overall, which worked out to a very small percentage in each case. And they were of particular kinds. So in the high SES child-directed speech, they took this form. What do you think that Jack read, right? So our matrix embedded object, right? Or sorry, our embedded object, not matrix. What do you think that Jack read? The what down here. And in our low SES child-directed speech, what do you think that happens, right? So it's our embedded subject with the complementizer that. And so the idea would be, okay, but if you get enough input over several years, which is our estimate as to how long we think it takes you to develop this kind of knowledge, even these rare cases are predicted to support learning because over time you just sort of encounter enough of these complementizer that pieces, right? And so in fact, if the samples are reasonably accurate, who knows, because again, these are fairly small samples, but this suggests perhaps that low SES children actually see this building block more often, just overall. So hey, yay, that's nice for the low SES kids. Now what's interesting, I think, and some of you may have noticed this, is that the low SES WH dependency, what do you think that happens with this complementizer that building block, is typically judged to be ungrammatical. In the high SES dialect, it's a that trace violation is the name that it goes by, right? High SES speakers generally kind of don't like it, right? But it's where that key building block comes from in the low SES child-directed speech, right? So low SES children then are predicted to achieve the same learning outcome, right, as high SES children. How? By leveraging key building blocks that involve complementizer that from sources a high SES child wouldn't hear, in particular these that trace violations, which are ungrammatical for high SES speakers, but that's where the key building block is predicted to come from for low SES children. So the takeaway then is that this is one reason why differences in the input, measurable differences, might not be developmentally meaningful differences. The building blocks that are important may show up in different places, but they're still present in the input, and that's the important thing for learning.